this video, we're going to talk about topic 8.2. We're going to connect position, velocity, and acceleration of functions using integrals. We are going to review some of our derivatives in here as well. So we're going to ask the question, how do you use an integral with position, velocity, and acceleration? And by the end, you're going to be able to say, I can determine positions and rates of change using definite integrals in problems involving motion. So in this video, we're going to particularly concentrate on the column on the left-hand side. So for physics problems, so if you know it's a physics problem if you see the words position, velocity, or acceleration in it. And we've seen some of these before. But you always, the first one way to write this down is IAVPD. So, and the mnemonic is I am very proud dude. Okay. What it stands for is integral, acceleration, velocity, position, and derivative. And we're going to see how it works. Well, actually, let's talk about it now. So basically, wherever you're starting, you circle. Okay, so if I'm starting at, let's say, position, and then it tells me I need to get to acceleration, that means that wherever I'm coming from is what I need to do. So since I'm coming from the derivative side, I know I need to take the derivative. If I was starting at velocity and it said I needed position, I would be coming from the integral side. So to get from velocity to position, I would need an integral. So just as a review, the position is the first derivative of the velocity. The velocity is the first derivative of the acceleration. And the second derivative of position is also the acceleration. Now, thinking about the integral, okay? So the velocity, the integral of velocity is position. The integral of acceleration is velocity. And when we integrate twice on acceleration, we get ourselves back to position. You want to make sure you always don't forget your plus C's for your integrals. A lot of times in these, we will have an initial condition, which we'll get to. If there isn't, that would really be replacing our plus C's. So for position, velocity, and acceleration, you need to think of it as a person standing on roller skates on a flat surface, okay? So if I think about that person standing on roller skates, all right? So here's my person. They've got roller skates on, okay? And they have two fans, one on either side, okay? Okay, and they're blowing at them in either direction, okay? So the position is where you are at. So where are you at? So that would be exact. So wherever the roller skater is, it's where the position is where they're at. The velocity is where you going. Okay. So the velocity is going to be whether you're rolling left or right. So that would be your velocity. And then the acceleration is where the wind pushing you. So that would be the fan. So where are the fans pushing the person on roller skates would be the acceleration. So this is the pushing there. All right, so we will use those items as we go and explain problems.